Alright, we're going to take a look at another application of the chain rule. And in this case, we want to apply the chain rule to determine dy over dx for y is equal to u times 2 minus u squared. And u is 1 over x, and x is equal to 2. Now we can notice here that u is a function of x, and y is a function of u. Okay, and we can also find a value for x as well, and x is equal to 2 here. So in this sense, if we want to find dy over dx, we understand that if y is equal to u 2 minus u squared, if we find this derivative with respect to u, we can call this dy over du. U is equal to 1 over x. If we find this derivative with respect to x, we can call this du over dx. Okay? But you want to figure out dy over dx. Well, if you want to find dy over dx, you can actually notice here that if you take dy over du and you multiply this by du over dx, right? So once again, this basically means the derivative of y with respect to du and the derivative of du with respect to dx. You can actually notice that the du's would cancel out, right? So dy over dx is equal to the derivative of y with respect to du times the derivative of u with respect to dx. Now, this basically shows us that we get dy over dx again. So I'm going to employ that. So I'm going to figure out what each of these are and then multiply together to find dy over dx. Let's first find the derivative of y with respect to du. Okay, so if we want to find the derivative of y with respect to du, to make my life easier, I could use product rule at this point, but I'm just going to expand this guy out and just use power rule. So you get 2u minus u cubed. So dy with respect to du is equal to 2 minus 3u squared. Okay? Now, so that's dy with respect to du. Let's take a look at du with respect to dx, right? So in this sense, u is equal to 1 over x. So u you can write as x to the power negative 1, right? So du with respect to dx is equal to negative x to the power negative 2, okay? And as a positive exponent, it's negative 1x squared, okay? And now that you have dy and dy with respect to du and du with respect to dx, if you want to solve for dy over dx, it's equal to dy over du times du with respect to dx. These guys cancel out, and then that's going to basically be equal to 2 minus 3u squared times negative 1 over x squared, right? At this point, what you want to do here is you want to, so now you have the derivative dy over dx, but you actually have it in the form of u and x. Okay, you want to try to make sure that all the u's are in terms of x. Okay, so to do that, what you want to do is you want to do a substitution. You know that u is equal to 1 over x, right? So you're going to substitute that for u, right? So you're going to get 2 minus 3 1 over x squared, negative 1 over x squared. Okay, and when you simplify this guy out, you get 2 minus 3x squared times negative 1 over x squared, right? Now at this point, they want you to solve for dy over dx when x is equal to 2. So I'm going to let x equal 2 here. So if you let x equal 2, you'll basically get 2 minus 3 over 2 squared times negative 1 2 squared, which is basically 2 minus 3 over 4 times negative 1 over 4, right? And if I simplify this out, you can write 2 here as 8 over 4. So 8 over 4 minus 3 over 4 here is 5 over 4 times negative 1 over 4, and that's going to give you negative 5 over 16. Okay, so therefore dy over dx when x is equal to 2 is equal to negative 5 over 16. Right, that's the rate of change when x is equal to 2. Okay, so that's an application of the chain rule.